You're now.
Hello. Am I audible, sir?
Yes, sir. Yes, sir. You are audible. You are audible, sir.
Actually, there was some network problem, so I got, but I didn't come to know that I am disconnected. I was just taking.
Yes,
Sir called and told me. Okay. So this is the.
Yes, sir. Such thing happens.
Yes, yes. This is the shortcomings of our technology.
Yes, sure, sir. You can continue.
Okay. I'll- Okay, so this is what I was saying. I don't know how much it has been covered. So let me go one more times. So what I've taken 2 points A and B, 2 points B, and I have taken a circle with radius R. It creates a slider with name R. So when I'm going to move the slider, both the circle is going to move, and it is going to change accordingly because the second circle, the radius is depending on R, and the first circle is also the first circle, the radius is R, and the second circle, the radius is 10 minus R. So what I told that you can go to the objective property of this slider. So when you are going to go to this object property, so when I'm going to right click, I'm going to get these options. I'm going to take the second option, last options, and there is option for this. Before it was from 0 to 5 by default, but I made it from 0 to 20. So I can change. You can, as your wish, you can change over here. 0 to 20, this means that the slider will take the value 0 first, then it will get up to 20 with an increment of 0.5, means 0.5, then 0.2, then 0.3, and it will go up till 20. So this is the property. There are other options also, as I told. There are like color option. I've changed the color. I can change the color of the slider to blue, green, yellow. So similarly, for every object, you can, these properties are there. Accordingly, whatever you want, you can change. There are options for positions, algebra, advanced, scripting. So because to get well versed with any software, the best thing is that you have to work with it. You have worked with Windows. Windows is now everybody cup of tea because they are used to it. They are practicing with it. Similarly, with any software, if you as much you work with any software, you're going to learn it. Right? So these options, you take one options. So those who are new to GeoGebra, you take these options one by one and see what is happening with these options. Okay, so now see the slider. When I'm going to change the position of the slider, it is going to give the complete ellipse to us. The complete ellipse. Okay, so this is how we can tell how the sum of if we are going to keep if we are going to define locus in such a way that there are two fixed points and the locus is such that the sum of distance from those 2 points are constant, then it is always an ellipse. So this way you can use GeoGebra software to find the locus. Okay. So there are some few more things which we are going to do, like we can trace parabola also. Tracing of parabola. Now, how to trace a parabola? So to trace parabola, we are going to use again. We are going to use these options because you have different options in your like circles, segments. So we are going to use it. So how to draw a parabola? To get to a parabola, the idea is that because how do you define locus of a parabola? For parabola, there is a fixed line. There is a fixed line. Okay, so there is a line, there is a point. There is a line, there is a point. So if you want to use these options which are available in the GeoGebra to find the locus, And how do you define the locus of a parabola? Locus of a parabola is defined by a point which is equidistant from this fixed line. Means fixed line equidistant means you have to draw a perpendicular over here. Then from this point, I have to join this point, and I have to see that whether this distance is equal or not. So keeping this condition into view, we can find the locus. But how to use the software? So for that, what we are going to do? I want this because I know the point and I know the line. So what I can do, I can get different perpendiculars on this line. Okay, I can get different perpendiculars. So what I'm going to do, the point of locus would be on the perpendicular, and I have to get to this point. So how to get this point? For that, we are going to do a little logical mathematical analysis, that whenever I'm going to, if I want this point, so what I'm going to do, I'm going to join this, and from here I want this. Since these two are equal, so if I want to locate this point, I will take the perpendicular bisector of this line. So wherever this line and this perpendicular bisector is going to meet, that would be a point which would be equidistant from the line, equidistant from this line and this point. Okay, so this is how so logically the student has to think. He has to use the different geometries which he has learned, the congruency property which he has learned. In an isosceles triangle, if you are going to draw the perpendicular bisector of the third side, which is other than the equal side, then it is always going to move through the vertex. So student will have to think about this thing. Then only he can find the locus. Okay, so let us see how we are going to use this in the GeoGebra. So I'm coming back to the GeoGebra. So let me open a new window. So I'm going to open this new GeoGebra window, and I'm going to use the same logic which I've used over here. So if I don't want the grid, I can move that grid. If I don't want the axis, I can move the axis also. So I just so that it is plain to us. So what I'm going to, first of all, I want a fixed line. So for a fixed line, you should have 2 points. So to fix the line, I should have 2 points. So I will take 2 points first. So I will take 2 points. So I will take this point. I will take another point. Then I'm going to take a line. So there is an option from here. I'm going to take the option of line. So this line, when I'm going to select these 2 points, so I will get a line which passes through these 2 points. Okay. So if you remember that, you should have a line. Okay, you should have a line. Then what? You should have a point, the fixed point from which you want to find the distance. So I have to take a point. So I'm going to select the option of point, and anywhere you can put it. So anywhere you can put. So you get the other point. Okay. So now what do you have to do? Now I have to take a point on this, which is movable on this line, because as that point is moved, our point, locus point, is going to move. So I want a slided type of thing. So what I'm going to take, I'm going to take any point on this line. So I took a point. So you got a point D. Now after that, what we have to do? We know that the locus of the parabola would be on a line which is perpendicular to this D. So what I'm going to take, I'm going to select an option from here, perpendicular line. So perpendicular line. So where I want a perpendicular line? I want a perpendicular line on this and on this line. So I got a perpendicular line. Understood? After that, what we have done? After that, so I can move this point. I can move this point. So when I'm going to move this point, this line is also going to move. So when I'm going to move this point, this line is also going to move. Okay. So when the line is going to move, then what we have done? So this we have thought before. So this develops a thinking process in the child. What he has to do? It's not just about the locus. It's about the thinking process. The process we have thought in mathematics. What I have to do, I have to make a triangle. From that triangle, I have to join this from join these 2 points. So what he is going to do? He is going to join these 2 points. Okay. After that, what we have done? We have because we know that I want the locus point. The locus point will be somewhere over here in this line, but it would be the intersection of the perpendicular bisector. If you remember what we have done over there, perpendicular bisector we have done. So we will take the option from here, which is the perpendicular bisector. So I want the perpendicular bisector of DC. So I'm going to select this. So when I'm going to select this, I'm going to get the perpendicular bisector. Since we have constructed this, as we are going to move the point D, these points are going to move. And where is our point? This is our point. This is our point. So I want the intersection point. So again, what I'm going to select from here, the intersection option. Intersection option I'm going to select, and I'm going to select what I want. I want this point of intersection. So I got this point of intersection. So this E would satisfy this condition now. Which condition? If I'm going to join this point, if I'm going to join this, so you can see that D would be equals to EC, because this is coming from a construction. Because this is line. So this line and this line would be equal. This line, DE would be equals to EC. So I want the locus of this point E. So I will take this option, right click on this. I will go on this option, trace on. And now as D is going to move, this point E is also going to move. So let me move this point. Let me move this point. Okay. Okay. So I'm going to move this point. So as I'm going to move this point, so actually that option is not selected. So I'm going to select it again, trace on. Then I'm going to move this point D. So if I'm going to move this point, you're going to see that. Understood? See, it's not just about drawing or tracing a parabola. It's about the concept which we are using for arriving at the tracing of a parabola. So how to use this thing. So it will develop the child thinking process. It will develop how to get through it, how to use these tools and arrive at the trace of a parabola. So these things we can use in our classroom, and my advice to all the teachers and to be teachers is that if we are going to use this, because many a times we are helpless in the class, we are not able to give our idea to the students, because normally in a classroom there is chalk and there is blackboard or whiteboard, and we use by just speaking we tell them this is happening, but to give them a feel of these things, these concepts, otherwise which cannot, because as in the beginning only we told that we have discussed that mathematics is abstract, to how to give them a feel of concreteness in that abstractness, this software would be of great help. So Ashish sir, do we have time?
Hello. Yes, sir.
Okay, if we have time, then we can move to some more other thing.
Okay, sir. You may continue for some time.
Okay. See, this is again. See, there are different options. So actually, the other window. So you can see that only the algebra window is being shown. So you can go to this view, and from view you can select these options. So there are options like graphics. So when you're going to click this graphic, the graphic window will also be shown. Okay, so this is actually one applet. So these are known as applets. Whatever is ready-made in GeoGebra, which I have constructed, but which. So in GeoGebra, once you create these applet, you can save them also. So once you can save them, you can use it. Once you have constructed, you can save them and you can use it afterward in your teaching learning process. So what I have done, you can see that. What is here? I want to show both these things. Okay. Okay. Actually, it is not fixed. That's why the problem. Nevertheless, just see what is happening here. Now it's okay. See, in this, what I have done, I have, there are other options also. Like this, you can see that from here, there are slider, then there is text. So in this, I have used these options, text options, image, button, check bar, input. These are different options. There are numerous numbers of options which are in GeoGebra. So you can use them one by one. So when you are going to work on it, then you are going to. So what I've done, I've taken a polygon, a regular polygon. I've taken a regular polygon, and I have circumcircled with a circle. Now this circle is circumcircled. So this polygon is inside this circle. There is a slider for this polygon. So when I'm going to increase the size of this polygon, what is going to happen? See, the size is fixed. You can see that the side is given by this. The side is this. Okay, the side is this segment F. So on the left hand side, you can see that segment F is 2.07. On the left hand side, you can see that the segment is 2.07. This means that these are the polygons. Only the side is increasing. But the length is fixed. It is 2.07 only. So when I'm going to increase this, hello? Okay, sorry. Okay, so what we are doing over here, what is happening over here, when I'm increasing this, and what is happening, the side is increasing, number of side is increasing, but the length is same. It is 2.07 only. So actually what I have done what for this pi. If I'm go to this property of this pi, object property of pi, you will see that there is an option over here. There is option over here, text option. Okay, so text option, what I've done, I have selected pi equals to. So pi is taken as a variable. So pi equals to variable, and this, if you can see this small rectangle type thing in which v is given, and this u is given, and this w is given. This v is actually the perimeter of the polygon. What is v? V is the perimeter of the polygon. And what is this u? This u is the diameter of the circle. U is the diameter of the circle. U is the diameter of the circle, and v is the perimeter of the polygon. So when you are going to divide it, what are you going to get? Let us see what you are going to get. As I'm increasing the size, what is happening? As I'm increasing the number of side of this polygon, what is happening? You're seeing that the area between the circle, because when it was the polygon of side 3, you can see that the area between the circle was very large. This area, you can see that this area. As I increase the side of the polygon, now quadrilateral, then pentagon, and so on. So what you are observing, the area, the side, the area is decreasing continuously. So from here, what all concept we can give to the student? We can give the concept of limit over here. So as n tends to infinity, this polygon is going to tends towards the circle. Okay, so this important concept of limit, where we talk about limit in class 11 intermediate. So the concept of limit can be shown by this applet, because as we are increasing the side, what is happening? The area is continuously decreasing. So you can see that what is happening, the area is continuously decreasing, and it is converging towards circle. So you can give the concept of convergence. Okay, so you can give the concept of convergence. And what second thing, from here we can give them a field of pi, which is an irrational number. Pi is an irrational number. So how pi is defined? Pi is defined it's actually a transcendental number. So what idea can you give about pi? As we are tending towards infinity, as this n is increasing, the area is decreasing. So actually what I have done the ratio of the perimeter of the polygon and the diameter of the circle. So what you are seeing, that as I'm increasing, see, it is the ratio is 3.14. Now see, as I'm increasing, what is happening? Just see, 3.16. Let me increase the font size so that you can see it. Okay, now it has increased. So let me increase it further. See what is happening. 3.14, then 39, 3.145. So as we are increasing, the precision of the pi is increasing. See, now the 3.145. 3.1456, 7. So we can give the idea of limit, and we can give them how pi, the constant 3.14, comes out. And you can give that as we increase the precision, is going to 5.18. It has become. It is going. See, now these are fixed. 3.1415. This has been fixed now. Now it is not going to change. So two concepts you can give from here. that 3.14 that the pi is 3.14. The constant that we take for pi, that is 3.14, and we can get to more places of decimal also, correct, to more places of decimal. So this type of applets we can prepare in the classroom, and we can, as a teacher, we can use this in the teaching learning process, and the students will also find it more interesting. And to learn the software, the only thing is that you have to work with the software. As much you are going to work with the software, you are going to learn this. There are numerous options. There are options. There is options where there are ready-made resources. So if you go to geogebra.org, you will get different options over here. There are options for resources over here. So number of applets have been made by different users, and they've uploaded it. So you can visit them. You can search your according to your choice also. So if for example, if I write limit over here, then I will get different applets which is related to limit. From here also you can get an idea how to create your own applet. You can upload your own applet. You can sign in. You can once sign in, you can whatever applet you are making, you can save it and you can use it whenever you are online. So there is no need to save it in your computer. Once the applet has been made, you can upload it, and whenever you are going to open those open it, sign in, then you are going to get that. So there are different type of so for example, I just written limit and see the number of applet which has already made on to describe the concept of limit over here. You can go to that. You can go to any of them. You can go to any of them. From here, there is an option. You either you can use them directly for the. For example, this is the epsilon delta definition of limit. Epsilon to explain the epsilon delta definition of limit. So you can use the slider. See the slider also you can use over here. And if you want, there is option for downloading also, so that you can download it. You can open it in your app also. Whatever app, you can share it also. So if you can open it in your app, so it will be open in the GeoGebra app. Okay, so there are numerous number of things which you can do. So I don't think so this 1 hour or 1.5 hour lecture would be sufficient to learn GeoGebra. But only advice to all the participants is that you just work on the software. Because any software, if you want, this is not with GeoGebra, any software or anything you have to learn, you have to work on it. And you are going to learn many things, and you will be very happy to use in your classroom. So if participants, if you have any doubts regarding this, you may ask. Hello, Ashish sir, madam.
Yes, sir. Thank you, sir. So, dear students and respected participants, if you have any questions, you can ask, sir.
Yes, Rekha ma'am, please. Rekha ma'am, would you like to floor any question? Any question from our participants? Really, it is sir, wonderful. Means you really you have visualized the abstraction.
Yes, sir. Actually, sir, only thing is that because just by showing, it's like a magician.
Yes.
Magician can just show that. But if you want the feel of thing, you have to do it yourself.
Yes, sir. Sure, sir. Sir, in between, I had sent the link, mobile link.
Yeah.
So many of our participants were practicing the same in mobile phone.
Okay.
But the interface is somewhat different. So,
yes, sir. Okay. Actually, in mobile, the full version is not there. So, but still you can use in the mobile. But it would be good if you can use your laptop or your computer, so that
yes, sir. This is the best one. This is the best one.
Otherwise, you can. There is an option to use in your mobile also. Now the GeoGebra has introduced a very good, nice, very beautiful option of augmented reality.
Yes, sir. In mobile, it's there.
Mobile is there, but I think so. It is for the Apple user.
No, sir. It's working in my phone.
Augmented reality is working in your phone.
Yes, sir.
Okay. So, but yes, but in the beginning they had introduced for Apple, but I think so they have extended for the Android user also.
Yes, sir. Okay. Actually, sir, in mobile phone there is a fragmented apps. Means there is not a complete what it is available in mobile phone. In laptop or desktop app. If I say here in mobile phone, you can see you go to your Play Store and search GeoGebra.
Yes.
You will get 5 to 6 apps.
Okay. So is there a specific app?
It is fragmented. Yes, sir.
So what is the name of that? Augmented. What is the name of that app?
3D calculator.
3D calculator. So in that augmented reality is there.
Yes, sir.
Okay, so all the participants, you can work on that augmented reality also. So there are a number of videos also, because this is a new thing. So there are few videos, but you will think that it's like you can go to the garden and you can bring hyperbola, conicoid, your hyperboloid in that garden, and in that same garden, that thing can be seen. So that I think that is a very good thing which is being bought by you.
And sir, for Apple users, it is named as GeoGebra AR.
Okay, augmented reality AR.
Yes. Sir.
Okay. Yeah.
For Apple users, it's AR.
Okay.
But any question from participants? Yes, ma'am. Rekha, ma'am. Hello, Rekha, ma'am. Your voice is not audible, perhaps. Hello. Okay, by mistake, she might have on the mic. It seems like that. But any question? Sir, here many of our students are also here, RI student as well as our Gajwani students.
Yes, I have seen some RI students also. Some.
Yes.
Who is the RI student over here?
Good afternoon, sir. Chandraprakash Chandan.
Chandraprakash, you are there. Any BSc BEd student from RI?
Yes, sir. Yogita was there, but
yes, I've seen Yogita. She was there.
Yogita was here.
Okay, because in our BSc BEd course, our students we have introduced practical for them. So a lot they do in GeoGebra. Other software, Mathematica, MATLAB also, but they do in GeoGebra also. So they are well versed with that.
सर, जो शुरू में आपने बात की थी मैथ्स लैब की, हम चाहेंगे हमारे स्टूडेंट और जो भी इंटरेस्टेड हैं, आप बाद में उसके बारे में बताएं और उसका क्या
definitely sir, we can plan another session for that.
क्योंकि सर हमारे यहाँ के सिलेबस में सिर्फ मैथ्स लैब का उल्लेख है. They have just mentioned maths lab and nothing else.
Okay.
And in exam also they will ask write a short note on maths lab.
Okay. Oh. No, actually, the what I was saying, I was talking about a software that is MATLAB. MATLAB. That is a software, MATLAB software.
Yes, sir.
Okay.
And who are the RI students? Sir?
I'm saying Mahen sir is also there.
Yes, sir. Mahendra sir is also with us.
Good afternoon, sir.
Yeah, fine. Everything fine.
Okay.
It was really interactive session, sir. I was there for a while in the beginning also, and then at the end I joined.
Okay, sir. Thank you. Thank
It
you.
was really interactive session. Yeah.
Okay, Ashish sir. Now what?
Yes, sir. And now I will formally thank you. Thank you. Wonderful and interactive session, sir. And for participants, if you visit RI Bhopal and who are their RI students, they are knowing Thomas sir and and the team have very well developed maths lab. And even today morning I was talking about Science Park. Even the models they have kept in Science Park also. So so whenever you visit RI Bhopal, you must visit this maths lab because it is beautifully planned. With
Yes,
this note, sir. Yes, sir. Manisha is here.
We have seen the journey as well, sir, of the development
Yes, sir.
of Science Park and Maths Lab.
Yes. Like you, I was same part of their journey. Manisha?
No, sir. Just one thing I wanted to say to Thomas, sir. It was a very informative session, sir, for me as well, because for biology students like me, mathematics has always been a very, a kind of phobia. So I really hope that all these things will help such students who are, having difficulty in understanding mathematics in a regular way.
Yes, definitely.
Thank you so much.
Because mathematics is also mathematics is not independent. It's used with different science subject also. Because without mathematics, physics cannot be done. So a good understanding of mathematics is, in fact, in biology also. We talk about mathematical biology. Many research are going in with mathematics and biology. So I think that in that case, it is very important.
Agreed, sir. Now I am understanding the importance of mathematics in life. I did not understand it when I was a student. So now that I am a teacher myself, I can understand it better. And thank you very much.
With this note, sir, thank you. Thank you from our institution, our principal ma'am, and from all organizing team. We are thinking to have one another session on maths laboratory whenever you are free, sir. अभी तो आपका भी सर प्रोग्राम साइड चल रहा है और आपने सर उसके बिजी शेड्यूल में से टाइम हमारे लिए स्पेयर किया. Thank you, sir. Really, we are very thankful to you.
I'm also thankful to the organizer of HR Gajwani College of Education for giving me this opportunity to interact. Okay, thank you very much.
Thank you, sir. Namaskar.
Thank you, sir. Thank you so much.
Okay.
We are starting our session soon. Our next resource person, Mahendra sir, is with us. Sir, please give us 2 to 3 minutes. We will starting. Mahendra sir.
Sure, Doctor. Sure. Yeah. You can avail your time as per your convenience.
Yes, sir. I would like to invite our faculty, Mr. Deepak Parmar, to introduce to Mahendra. Deepak sir.
हेलो, आवाज आ रही है सर?
Yes sir. Now you are audible.
ओके, थैंक यू सर। आज का हमारा लास्ट सेशन वर्कशॉप का मैं डॉक्टर महेंद्र दत्त परिचय कराऊंगा। डॉक्टर महेंद्र दत्त presently working as an assistant professor in the Department of Education, Tagore Government Arts and Science College, Pondicherry. He had been recommended by UPSC for this post. UPSC for this post. Earlier, he had worked at RI Bhopal. He had 15 years of teaching experience at various levels. He had been awarded PhD degree by Devi Ahilya Vidyalaya, Indore. He has more than a dozen scholarly research papers at this credit published in various genres of repeat and as chapters in edited book. वेलकम टू सर, आज का सेशन आप शुरू कर सकते हैं सर।
Thank you, Deepak sir. Thank you for this short but sweet introduction. First of all, I must congratulate Dr. Rashid, Dr. Tulna ma'am, and the team for this well-planned, well-organized workshop. Except some few snag at the beginning in the very first session, I couldn't find any loophole in the previous sessions. In between, I attended,